Welcome to FutureLab's mentor class. We're very excited for you to be here. So I believe many of you here tonight could be the first time joining our mentor class. Maybe you guys are here as a first timer, but maybe some of you have already been at FutureLab for quite some time right now, right? So just to share, the reason why are you guys able to join tonight's mentor class is because you guys are officially FutureLab mentees, all right? So just to share with you who is FutureLab and what do we do. So we are a social enterprise and our aim is to be able to make mentorship accessible to all. We believe that, regardless of your financial background, regardless of your socioeconomic status, regardless of your upbringing, we want to ensure that everybody deserves the resources in order to attain their career goals. Now, why do we believe that mentors play a very big role in terms of helping you to accelerate your career journey? Is because mentors actually help you to fill that gap between who you are today and who you want to become in the future, right? So through that, mentorship is the key to help you to find a meaningful and fulfilling career. Okay, so FutureLab have been around for about 6 years now, and we have conducted over 50,000 mentoring sessions ever since 2016. We have impacted mentees all over Southeast Asia. So we have run events and programs, not just in Malaysia, but also in Singapore and Indonesia as well. All right, so without further ado, I would actually like to pass the floor to our event partner tonight. So we have Shoyi, who is the CEO of Social. Okay, so Shoyi, take the floor.
Yeah, thanks Pik for the introduction and also invitation. So I'm Shoyi, and let me share my screen real quick. Thank you.
Please give Shoyi a couple of moments for her to start. Okay,
yeah, okay.
You're all good.
So yeah, all good. Thank you. So hi everyone, I'm Sherry, and thanks FutureLab for the invitation. And I'm the CEO of the Malaysian Social Project. So based on our mission and vision on the screen right now. So basically, we are a non-profit volunteer-based consultancy for the third sector. And since 2018, yes, we are 5 years old right now, and we have been developing socially conscious leaders through our projects and our very own community team. So here at Social, we believe that our programs, as we shown earlier, right now on the screen, the red color highlighted in the text box, we believe that our programs can help to provide the third sector with pragmatic and data-driven solutions should they lack of the resources and flexibility to produce themselves. So here is how we step in. Think of us, Social, as a bridge, bridging the aspiring Malaysian youth, everyone here, to the third sector, mentored by the top-tier consulting firms like BCG, Bain, and Kearney. To date, we have served over 30 clients. Oh, sorry, one moment. Yes. So, one moment. So basically here, all the programs are actually our flagships, and also our master class and also bootcamp are also for our upcoming initiative. So we have actually served more than 30 clients throughout these 5 years. And for now, we would like to actually invite everyone here to actually join us as a team. So internally, our team, so actually maybe you could wonder, so how will you actually play your part? Okay, so we have around 6 diverse portfolios here with 2 tiers of team structure. So basically, if you are keen to actually take care of our community, or even establish our digital presence in social, this is the right place for you, and we actually look forward to actually collaborate with every one of you. So internally, our team is actually quite diverse, and also we are coming from different background. Yeah, thanks Nicole, and also thanks Vivian. Sorry for that. Yeah, so basically our team are actually teamed up with diverse disciplines, backgrounds, and also universities locally and also internationally. So basically from here, you can actually meet a lot of like-minded peers, but we actually all share with the same passion of actually serving third sector while upskilling ourselves at the same time. So actually, sorry for all the hiccups just now. Didn't really manage to actually get through it. So basically, here's the link for our early interest form, especially for everyone here, exclusive only for FutureLab, for our collaboration. And feel free to just join us. And also, here's the place for you to actually upskill yourself at the same time, personally and also professionally, no matter what kind of like industry are you keen on, and also fostering meaningful connections. So here's the link. Slide in our Instagram, check it out, and feel free to let us know if you have any questions. Thanks again for this session, and very sorry that for the hiccups just now. Yeah, thank you very much. Thank you.
No worries. Thank you so much, Sherry. So I definitely agree. Social is an amazing organization. If you are looking for an opportunity to, have a sneak peek into what is it like to become a management consultant, you guys should definitely check out Social and also become one of their members. All right, so thank you so much, Shoyi. Without further ado, so can I present my slide? Thank you so much. All right, so I guess the moment that we've all been waiting for is coming. So let us introduce our mentor for tonight. Her name is Pik Yin. She is currently the data scientist at RPS Group. All right, Pik Yin, you may take the floor.
Hello, everyone. Thank you so much for spending time, taking this an hour on your evening to participate in this one. So I just want to, before I share my screen, I just want to give you a very brief introduction of who I am. So yeah, my current role is a data scientist in RPS Group. So RPS is an engineering management consulting company. And before that, before being in this role, I was actually a data analyst for more than 3 years. And my major in university is actually statistics. And then I completed my Master of Data Science in 2020. Yeah, so I'm very glad to be given this opportunity to be sharing some basics about my experience and how to use Google Sheet. So without further ado, let me share my screen and then yeah, give me a thumbs up when you can see my screen. Okay. Wow, the screen share is taking a longer time than I expected. Okay, is it visible now? Just now It was loading.
Okay, yes, it's all good now.
Okay, so the title of today, learn to use Google Sheet for data analysis and visualization. So I just want to give like a disclaimer. So why do we choose Google Sheet is because it's free. Like if you have Gmail, you can use it. Unlike any other data analytics platform, which is like, for example, Excel, you need like the Microsoft license, which is probably not available for everyone. And also some other data analytics software like Spotfire, Tableau, Power BI, they all need license. So Google Sheet is like a very like an open source and easily available canvas for you to do data analysis and visualization. So yeah, that's why we choose Google Sheet. But everything that I'm sharing today is transferable to other platforms. Okay, so here you can see this whole flow of data analysis, right? Data analysis is just a part of it. So so if we take a step back, why do we do data analysis and visualization? Is because we want to change that data into insights, right? What do I mean by insights is some actionable recommendation that you can give to the stakeholders in your company, right? Like your manager, you want to persuade him or her. So what do you do? Like you need data, you need facts to support you. So this is basically why we use data visualization and analysis in like the corporate setting or in the business. because we want to give actionable recommendation. We want to persuade the decision maker to make changes, right? Supporting by facts and data, okay? And then the first step will basically be data acquisition, where you get your data, right? It can be from the database that your company already have, usually is SQL or SQL. And then, or if you are if you're a last year student doing, a project, then could be your own survey. And then lastly, could be open source data, right? That is available out there for free to download. The second steps will be data preparation. So which includes some data preprocessing and data cleaning. So when I say data cleaning, meaning your data, usually the real life data is not as clean or not as precise or accurate, right? Sometimes you will have typo, sometimes you will have missing data, sometimes you will have, if you do not curate your questionnaire very carefully, you might get an answer that is outside of your option, or or something that you might not be able to analyze, right? So this is in data preparation, and then we go to data analysis, which basically it's divided into two parts. The first part is exploratory, where we do visualization and then we calculate some statistics to explore data, just to take a glance, get to feel the data, like to know what is it how does it look like, right? And then the next one, it involves hypothesis or some questions, like you have some questions on your mind that you do not have answer yet, but the data can provide you with the answer. So this is called explanatory data analysis. So exploratory and explanatory. So today I will only be covering the data analysis part, and majority of it will be exploratory, right? Explanatory, I will just give some example. And then the last one will be the communication, right? Which is where you report it, or you make a presentation that, for your manager, for your boss to persuade them. And then you start your data storytelling. You start to join all the insight, all the information that you gain, all the insights that you gain, and then you give recommendation to the decision maker. Okay, so this will be the scope of today, right? And then this will be the agenda. We'll talk about data type very briefly. I'll talk about basic statistics, what is mean, mode, median, what is variance, what is standard deviation. And then the second part, we will focus on the demo in using Google Sheet, right? So if you have any questions throughout the lesson, you can ask at the end of the lesson. But if you can't remember it, just feel free to type it in the chat box. So we will look at it one by one after the presentation ends. Okay. Okay, the first one, data type. So data type is really categorical, numerical, continuous, discrete. I'm sure you have heard of it, but what is beyond that? What is the foundation of it? It's actually the level of measurement. So instead of the data type, we talk about level of measurement first, and then I'll let you know why is it important to know about level of measurement. So level of measurement, it's only for, we have 4 types: nominal, ordinal, interval, and ratio. And then nominal is basically just categorical data. So the order is not important. So for example, the species of flowers, the mode of public transport, no one gets a higher rank than, based on the name, no one gets a higher rank than anyone else, right? It's categorized. Your name is also nominal data, right? So this is the first level of measurement. And then we go to ordinal data. Ordinal data is something that you can rank, but it's still categorical. For example, high, medium, low, right? For example, level of priority, of all your tasks, right? High, medium, low, urgent, not urgent but important. Is categorical, but it has a rank. You act upon the rank, right? Or in a competition, first, second, third, right? What is the ranking? So these are all ordinal data. And we have also interval data. So interval data is something that is evenly spaced. Okay, for example, temperature. So how temperature is interval. So 0 degrees Celsius is actually the freezing point of water, right? The moment where water turns to ice. So if someone is studying physics, please correct me if I'm wrong, right? So that is 0 degrees Celsius. And what is 100 degrees Celsius? 100 degrees Celsius is the boiling point of the water, right? So imagine you have a thermometer with mercury without any measurement, and then you put it onto an ice, right? And then you mark you mark there 0 degrees Celsius, and then you put the same thermometer to 100 degrees Celsius water, and then you mark 100 degree. So you have 0 to 100, and then you evenly space them, right, from 0 to 100. And you can use that thermometer to measure body temperature, right? Because you know exactly where is 0, you know exactly where is 100, and then you evenly space them, right? So it's interval. Same goes to time. So time is interval data because it depends on how the Earth is rotating, right? So when the sun rise and the sun set, right, we evenly space them into like 12 hours, or I don't know how many. Yeah, I think it's 12 hours, and then another 12 hours. So it's evenly spaced. So we evenly space our time and the temperature based on a certain condition, right, or scenario. Or the most frequent that you can see from any survey, like rate your satisfaction from 1 to 5. So basically you assume that everyone has the same impression on dissatisfied and very satisfied, and then you evenly space them into 1 to 5. So that is called interval data. And then lastly, we have ratio data. Ratio data, okay, the difference between ratio data and interval data is that ratio data has natural zero. So what do I mean by natural zero? So in ratio data, if I say 0, means it's nothing. For example, my exam score, if it's 0, then it's 0, right? The 0 is real. But when you go to temperature, would you say 0 degrees Celsius is no temperature at all? No, because when you put your hand on the ice, you can still feel the temperature. So 0 degree is just a marking, right, that we use to and evenly space so that we can measure something, right, like time and space and satisfaction. But ratio data is more it's not it's the 0, it has a meaning. 0 means nothing, right? Okay, so if you are the number of, for example, the number of books that you have, if it's 0, meaning you don't have any books. So that is what it means by natural zero. And this is why we have interval and ratio data. And this is very important because when you go to the next one, the next level, the next chapter or next session, this level of measurement will give you a guideline on what statistic to be used and what not to be used, right? So that you don't confuse people with bad statistics, right? Okay. Okay, so we have measure of central tendency and also variation. I know this is like a lot of like jargon, right? But it's okay that you don't get it like the first time. But I advise you to remember this term so that you can Google it afterwards yourself, right? So yeah, but these are the terms that will help you to get into the beginning of statistics and help you with to be better in understanding statistics, not just in your company, but sometimes when you look at some public statistics published by our government, our Department of Statistics, right? You will understand better how this is being calculated and how it affects decision making in even the public the public policy, the government policy. Okay, so the measure of central tendency, we have 3: mean, mode, and median. Mean is the average, right? So like I have 10 numbers in my data set, and I want only one statistics to represent that 10 numbers. So I choose the mean, right? The average of all, right? To use it to represent the whole data set. That is what it means by measure of central tendency, which means you choose a number to represent, right, the whole data set that you have. Okay, and mean is only used for interval and ratio data only, because it's meaningless if you have categorical data or nominal data. Sorry, you have nominal data or ordinal data, right? It only, so interval and ratio, interval is temperature, right? Average temperature of the month, average rainfall, right? So this is the mean. And then but it has a problem. It's extremely sensitive to outliers, right? So outliers, another jargon. Okay, so outliers is a data, a point, a value that is very far away from the others, right? It's very far away from the rest of the data set, right? So later I will talk more about it as well. So this is mean, but it's extremely sensitive to outlier. So sometimes when we see categorical data, so you don't, I know it's very basic, but people still make this mistake where they apply mean or average to nominal data or ordinal data, especially if the nominal and ordinal data are represented in numbers like 0, 1, 2. It's basically a code. It's not like the real number, right? So mean doesn't mean anything when it's being applied to ordinal and nominal data. And then the center one is the mode, right? The mode, yes, you can apply it for all measurement, all level of measurement. So if let's say you have category data and ordinal data, and then the mode is actually the most common data, right? So for example, like I have like that I will show you more example, but the mode is basically the value that carries the most common number, the number that has the most frequency in the data set. So if I have 1, 1, 1, 1, 0, 0, 2, then 1 is my mode because 1 appear, so many times in my data set. So because it's a categorical data, or I mean all level of measurement, I can use mode to represent the whole data set, right? So this is mode. And then we have also median. So I'm not sure if you read through the articles on the income of Malaysian, right? They don't usually use average income or mean income. So in the Department of Statistics report, they always use the median income, right? It's because we use median to find data which is in the middle position, right? They are not the average, but the middle position. So if I have 10 data sets and I rank them from ascending or descending order, I find the data which is at the middle position, which is between fifth and sixth position, right? That data that falls on the 5.5, like the middle position, is the median, right? So I'll use Google Sheet so that I can explain it like better later. But just remember these three terms: mean, mode, median. And then median is used when the distribution is skewed. So when the distribution is skewed, we don't use mean, we use median to represent the whole data. So these are just the theory that you can refer back. But after that, when I show you an example, hopefully you will have a clearer understanding of what this three means. But just right now, just plan, just have these three terms in your head first, right? Mean, mode, and median. Okay, and then we have measure of variability. Just now we have statistics to tell us, what are the central variability that can represent a whole data set. And this one, measure of variability, tells us how dispersed in the data, how spread is the data, how dispersed is the data, So we have range, range. So what is range? Range is the maximum number in a data set minus the minimum number of a data set. So for example, in a news article or a survey, we can say that, our respondent is between 18 to 60 years old. So 18 is your minimum number in the data set, and then 60 is the maximum number in your data set. So this is a range, right? It's very common. And we have interquartile range. So interquartile range, also like a new term, but I will show it to you later so you understand it better. So interquartile range is also dealing with precision, meaning if I have an array of data, and then I chop the data into 4 parts, because quartile it's quadrant, right, for 4 parts, right? So if I say Q3, meaning this third quadrant, so it's the 75 number. So the value that it's at the 75 position. I mean, if let's say I have 100 data, and then if it's Q1 is the data at the 25th position, of my data after I sort them, right? So here I will show you like how to calculate it in Google Sheet, like manually, just to show you the concept. And then we have variance and standard deviation, which is like short form SD, standard deviation, which basically tells you how far is each value from the mean. So let's say I have the mean. Okay, I know the mean already. The mean is 5, right? And then I have 10 data with me. So I take all the data set and then I subtract the mean, right? So I get the difference between the data point, each data point with the mean, right? And then I do some calculation and then I get standard deviation and variance. So basically it tells me how far away, what is the difference between each data point with my mean. So it tells you, it quantifies how diverse or how different, how apart is your data from the mean, because mean is your central value that you choose already, right? So this gives you a sense of how dispersed is in the data. But although we have this to measure variability, I do prefer looking at variability or dispersion using visual, which we will explore more in the Google Sheet demo later. And then just now I mentioned that you cannot use mean when you have a skewed distribution. So what do I mean by a skewed distribution? So here, this distribution is normal, right? It's like, we call it a bell curve, like it's almost symmetrical, right? It's symmetrical, right? So you have mean, mode, and median at the same value. So it's a normal distribution, or I mean, it's a symmetrical distribution. But when I say it's skewed, meaning most of the data, so how do I get this? This is the frequency, this is the number, this is the frequency. So meaning this is the frequency of people, this is the number of people that get SAT score 1150 or between here and here, right? This is the frequency. So in an ideal world, we would have this distribution, but in the real world, we will usually have the skewed distribution, mainly. So meaning a lot of the data is centering or concentrating at one side instead of, symmetrical, instead of like two sides of the mean of the central value, it's skewed. So here, you can see most of the data, because this represents frequency, right? Most of the data is skewed to the right. That's why we called it left skewed. Yeah, I know it's confusing, the left and right, but basically this is how the skewed data looks like, right? Meaning it's not at the center, but it's, most of the data it's centering at, somewhere the left or at the right. So, and then this is when we use median, because median is the central value when a distribution is skewed, not the mean. If you give mean as the central value, then it could be misleading. Okay. So yes, so we are here in the Google Sheet demo. So let me go out from this on this like rigid or structured presentation slides, and I will show you oops, sorry. And I will show you, yeah, how do I move this? Okay, yeah. Okay, I'll show you this first. Okay, so this one is the USM website. So this is where they publish statistics that is related to your day-to-day life, or about you, because you are part of the census or their estimates, right? So if you scroll down here, and you can see that the way they report the monthly income is using median, right? And it's not mean, because in many countries, income is something that is always skewed, right? So here, this is their, I cannot zoom in. I'm sorry, I don't know why I cannot zoom in this web page, but you see they report two statistics. One is median and one is mean, right? So if it's mean, you can see that it's a lot more higher than median, So if I go back to my slide, if mean is higher than median, what does it mean? So you can actually compare mean and median. And then if you see that, okay, if you see that mean is more than median, meaning, you know, our income distribution in Malaysia is actually this one, meaning majority of Malaysian has an income, you know, at the lower side, because this is 0 and then this is like higher income. So most of us, it's here, right? That's why using mean to represent like the population of Malaysia and saying that, oh, we have a average income of 7,000 is actually misleading, because this mean is extremely, you know, extremely sensitive to outliers. Meaning if you have like someone who have like a very high income at this site, because this line x-axis here basically means income from 0 to, you know, infinity, or like a number, like a big number. So, but very small percentage of people or low frequency of people have this, you know, it's in this income bracket. So meaning Malaysia is here. So that's why they always use median when they report income in Malaysia instead of the mean. Okay, so I need to go up from here. Okay, so, okay, yes, and then we can finally start the demo. Okay, that is a blank canvas, so that, okay, I can show you the mean, mode, median, right? So what I mean by mean is very extremely sensitive to outliers. So if I have a data set, so I just take generate random. So what I'm doing now, I'm just generating like random numbers between 0 to 10. Okay, and then I do the same, but I put in an outlier. I put 50 here, right? Should be an outlier, I think. So this one, I just add one more number so that they have the same number of data point. And then I start to calculate the mean. So using this formula, average. So you can see a big difference. So if let's say I tell people 11 is the central value, is the mean of my data set, it could be misleading, because apart from this 50, none of the numbers is more than 10, right? At most is 10. So how can you have 11, you know, as your that is representative of your whole data set, right? So this is a misleading number. So the truth is actually 6, right? So this is why we say average is the mean, is very sensitive to outliers. That's why when we are doing data analysis, it's important that we find out like which data point is the outlier, and then we rule them out, right? And then we try and find the reason why is it an outlier. Is it a typo? Is it wrong data entry? Is it inconsistent maybe unit of measurement, like I wanted meter, but they gave answer in cm, for example. So you try, so it needs to be separate out from the rest of the data, so that you can find out why is it so different from the rest, right? That's what we call outlier. And then okay, so I did this one because this is the mean. So I wanted to let you know how I calculate median manually. So I know it can be done here, you know, just choose me. That's why you need to know the terms, because it will help you when you're using a formula here, you know what to type. Okay, so this is the median. It's 8. It's also 8. So although we have outlier in this data set, but we get the same number in median, because median is not being impacted by outlier, right? Because we take the data from the middle position. So apart from 50, right, all the data sets are the same, right? So this is not impacted by, so this is just a little experiment that I did here, right? You can also play with it in Google Sheet, right? To understand median, mean, and mode. So okay, mode. yeah, mode is 10, like it's also not impacted and it can be used. So when you have outliers, if you haven't ruled out the outliers, please do not use mean. And if you have skewed distribution, use median. So let me try and show you how I calculate median manually. Okay, so oops, sorry. I just need to give it a header so I can. Okay, so I sort them first. Depends on you, descending or ascending is the same. And then their position. So I have 9 data set. So the middle of 9 is 3. Yeah, it's actually here. So it's the 5th position. Why? Because this position separates the data into equal 2 parts. 4 data point here and 4 data point here. That's why this is the median, right? Because it's in the middle position. So that is why the median is 8. And then it's not being impacted by outliers, because outliers, if you sort it ascending or descending, if it's extremely small or extremely large, it will not impact your, your median, because the value in the center position will not change. Okay, so this is when you see median, hopefully you remember this example. So okay, mean, mode, median, and then standard deviation, variance, and also range, interquartile range. I will talk more about it, but I will definitely recommend you to visually look at the distribution rather than calculate standard deviation and variance, because it's usually being used in scientific journal, right? Sometimes you will see mean plus minus SD, right? Yeah, in reporting, but it's very difficult to interpret it or make sense for non-technical stakeholders. That's why usually the visual will help you more. That's why data analysis will always go hand in hand with data visualization. So yeah, this is like basically the theory part. Now we go to, we see the everything in action, right? Okay, okay. So here, this is the data set that we're going to use today. Is diabetes data, right? It's an open source data. So let us look at the metadata. So the metadata, another jargon. So metadata is a document or a data that describe the data, that describe the raw data that you have. Basically the information about the data that you are really trying to use, right? So it's good to, keep this documentation. So for example, we have a lot of different columns here and then rows. So usually the data that you will encounter in your business world, like in the business world or in your survey, right? In your Google form, after you collect it in Google Sheet, it will be in this form, right? So each row represents a sample or observation, and then each column represent the different variables or features or questions or things that you want to measure, right? On this sample. Right, so in this data, we have 768 data. And then these are the different columns. And then, so we go to the metadata. So when I download this data, I also copy its metadata. So I understand what each column is trying to tell me. So pregnancy, what does it mean, right? So it's number of times pregnant, right? So these data set, it's from a long time ago. It's all patients, all the patients, they are female, and then they are at least 21 years old. That's why it doesn't like specify like gender or, yeah, it doesn't specify gender, but this is from them. And then you can see, and then this pregnancy makes sense, because if you have like a patient that, they couldn't be pregnant, like the male patient, then it wouldn't make sense, to put this, right? And then glucose, what does it mean? Like all these medical terms, right? So metadata is very important. So what makes you different as a data analyst and someone who knows statistics is how you tie this data to your business context, right? So I think data can be found in like almost every industry. And the reason why we still need human, right, in doing data, and there's a lot of job has been replaced by AI. So why do we still need human is because you need to marry this data with the business context. You need to know, how do I interpret this data? Okay, so I can get mean. So what does this average numbers mean to me and my and the problem that I'm trying to solve, right? Or the story that I'm going to tell my manager, right? So so having metadata is very important, because this gives you an opportunity to understand the problem, understand the context, instead of just looking at the data. Okay, I have this, now I have numbers, okay, and then I know their statistics, but so what? So what if I know their statistics, right? How can I bring changes or persuade others with the insights that I can find? So this is just data. The statistics is also data, but how can I turn this into insight is the most important thing, right? So today we're not going to do like a case study because we don't have many time, but this is the most important thing that you have to keep in mind, right? Which is the bigger picture, which is the business context when you are doing the analysis. Okay, so we touched about this. Okay, so you can see this ID, right? And also actually this age group is in gray because I created them myself. It's not from the original data. So the reason why I need ID is because it's useful in the visualization later, okay? And then the reason why I create this age group is because I want to show you that you can turn the data into categorical data. So age group, right? How do I create this? It's using a very basic if-else statement or nested if statement in Google Sheet, like this formula, or you have encountered in Excel. So I try to group the patients into different age group, right? So, but because originally age is the ratio, okay, numerical data, continuous data. But now, when I make it into a subgroup, which I think is meaningful for my research, right? It turns into categorical data. It turns to nominal data. Maybe this is ordinal data because it somehow have some ranking, right? If you want to rank the age from older to young to old, yeah, it's an ordinal data. So this is how you change the level of measurement or data type. And then the Google Sheet has a function which allows you to to define the data type, which is very important, which should be the first step that you need to do, right? After you read the metadata, you know what exactly all this mean. For example, this outcome 1 and 0, 1 and 0. So what does it mean? Is it categorical? Is it ordinal, nominal, interval, or ratio? So you look back at the metadata and it tells you it's an outcome. So if it's 1, meaning is with diabetes. If it's 0, meaning is without diabetes, right? So you know, okay, this 0, 1 is not a numerical data. The mean and the median is definitely not meaningful, because this is just this is categorical data, this is nominal data, and then they just code it with 0 and 1. So you need to understand all this, the metadata, or you need to understand all these columns, like the meaning of this column, then only you can start your analysis, right? So what you do is you highlight this column, not the header, just the value, and then you go to this format, and then you can see here number, and then you can see this automatic, meaning when you put this data, when you paste this data into Google Sheet, it automatically tells you already, like try to detect what kind of data this is, and then it's telling you it's a number, okay, which is true, like pregnancy, it's a number. Okay, for this one, ID is not a number. ID is just a code that I assign to my patients, to each sample or respondent in my data. That's why when I highlight this one and I click format, I have changed it to plain text. You need to explicitly do that, or else when you do data visualization, the Google Sheet will misunderstood this column as a column that is, as number, right? So the way, that's why I need to know the data type very well. And then the outcome. Okay, the outcome also is plain text. So I change it to plain text, right? Instead of, number, or else it will mistakenly think it is a number, right? And then it will ruin all your data visualization. So this is, you know, what you do, right? After you get the data, like assume that everything is clean, everything is pre-processed, and then you need to find out the data type, and then you need to understand each column, right? Some columns might not be useful, so you can just discard it to make it smaller. So it's also part of data cleaning. It's actually an iterative process, cleaning and pre-processing and also analysis. So during your analysis process, when you think something is very off, then you go back to clean it, and then you go back to analysis. So it's an iterative process. Okay, so we have done this, and then I'm going to show you the first analysis that usually we do. It's called pivot table. So you just highlight everything, and then you insert pivot table. Oh, before that, sorry, before that. Okay, so just now we talked about all these different statistics, right? So Google Sheet has this cool feature right now, right? That I think they just developed it recently. So if you go to data and you go to column stats, just click this, you can see this panel coming out, you know, at the right hand side, and then you start scrolling it. Yeah, it will show you the count and distribution, you know, of different columns. Yeah, which is pretty smart, right? Yeah, so this one you can use it to, you know, to glance, and then if you scroll it down, it will show you all the different statistics that I've mentioned, like the average, which is the mean, the median, right? The minimum and the maximum, which for you to calculate the range, right? These are the different, and then yeah, then you can sort it. So this is like a cool feature, right? So we can slightly glance through all the columns that is in number or continuous data format. That's why if you ID no data, because it no is not a number, because I specify as a plain text, so it doesn't give me any statistics because it's meaningless, right? Right. That's why it's important for you to know the data type. Yeah, the outcome no data, because I specify it as a plain text. Age group no data, okay, because categorical data. Okay, so this is the one cool feature. And second, where you can get this is if I just highlight glucose, and then you can see right hand side here, and then I expand it, I can see the sum. The summation is not, I wouldn't say it's meaningful in this case, because it's per patient based, per patient basis, so it doesn't meaningful. But you can see, you know, you can get mean, minimum, maximum, count, right, very easily from this right hand side. So these are the places where you can get like statistics already without using any formulas, without, you know, manually calculate it, right? Okay, so yeah, now we go to the pivot table. I feel like we don't have much time to cover all the materials today, but yeah, that I'll show you. So pivot table, and then existing sheet, because I already have a sheet, and then is it working? Okay, now I created a pivot table. So pivot table basically, and then I'll let you know why I need ID, right? Because if I put ID here, I'll have the count of the respondent that I have, and then I add more to the rows and column. You just drag and drop, and then you can play around with many things. And then I put age group. Then I will know, you know, my respondent by age group. Or if I don't want, and then I can put row pregnancy, that I know respondent by the number of pregnancy. So so for here, okay, we'll do this exercise, right? So what is the mode of the pregnancy column? What is the mode? Okay, the mode is actually 1. So the mode is not 135, the mode is 1. 135 is the frequency of the value, right? So 1 is the mode. So when I tell you 1 is the mode, you know majority of the sample in my data set has at least pregnant once. I mean, like has a number of pregnancy equals to 1, right? This is the mode. So mode is not 135. This is only its frequency, but 1 is the mode, because 1 is the number that appear most frequently, appear for 135 times, right, in the data set. So this pivot table. So you can play around with it. Okay, the next thing that I want to talk about is distribution, which also okay, so I'm having BMI here, right? So what I did was I created this histogram. So histogram is the term that we use to plot this distribution curve, right? We call it histogram. And you can clearly see that here we have this pound of data that is away from the rest of data. So this is where you can spot outliers immediately with visual, right? And then how do I plot it? Yeah, you can click edit the chart, and then you can see how I plot it. So later on, I'll ask the thing to share with you all this worksheet so that you can explore more. Since we are running out of time. So yes, this is the histogram, and this is how you visualize it, right? You just need to highlight this whole column and then click insert, click chart, and then it's smart enough to know you want a histogram. So this will pop up, right? You can try it yourself. And then we also have something called box plot, which you need to know. But box plot is not available in Google Sheet. Google Sheet only have something called candlestick, right? So if I create this subgroup, BMI is BMI for everyone without diabetes. So without diabetes, meaning I only take the number of people that is without diabetes, right? Outcome equals to 0, and with diabetes. And then I highlight them. I click insert. I click chart. I don't want this chart type. I want to change it to candlestick, right? So this is another tool that is very useful in visualizing distribution. It's called box plot, but Google Sheet doesn't have it. But if I plot it using candlestick, which is a alternative, which is okay, but not the best, you can at least see that the patient with diabetes actually has a higher BMI than others. You can see that, you know, this majority of the data, it's here, and then it's slightly higher than the group of people without diabetes, right? So this is actually another analysis that you can do by separating the people into subgroup that you think is meaningful, and then you compare them, you know, compare the distribution. And then outliers, these are the so outliers. So this is the one of the way to remove outliers by looking at numbers, not visual, is by using you know, plus minus 1.5 times IQR. IQR is Q3 minus Q1. So just now I mentioned about so here, if you look at here, you can see how it's being calculated. It's also with a formula. And then it means that you separate your data into 4 quarters, and then the first quarter is the one at the 35%. So if you have 10 data set, the 2.5 position, right? 2.5 TH position value is your Q1, and then the Q3 is the same, but it's 7.5 TH. You know, the position, that data is your Q3. Okay, so what else do I Sitting, do we have more time? Because
yeah, I think maybe another 5 minutes.
Okay, sure.
Yeah.
Okay, so this is histogram, and you know how we use visual to rule out the outliers if we don't want to calculate them, right? But this 0 is probably a mistake or a missing data, and then they decided to replace it with 0. That's why we should definitely be removing all the 0, because 0 BMI means nothing, right? 0 BMI, it's not logic, right? So this is how you look at it, and then you know, okay, there's something wrong with the data. That's why I go back to clean my data, and then I continue with the analysis. Okay, this one. So number of pregnancy again in a pie chart, right? So if I want you to quickly tell me which number of pregnancy is ranked the second most common, we know the most common is 1 already, is 135. So what is the second most common? Is it 0 or is it 2? Can you tell me, is it 0 or is it 2? Right? So if you want to put in the chat box, or you can remember your answer. So if you cannot quickly find it, so if I change the same data, but I change the visualization to bar plot, is it clearer? Like if I want you to quickly find me in 2 seconds, quickly find me which is the number of pregnancy that is ranked the second highest, apart from 1. You can actually immediately spot is this one already, which is 0. Right? So this tells you bar plot, horizontal bar plot is actually far more audience friendly than pie chart. I would advise everyone to avoid using pie chart or donut chart or its variation, right? Especially if you have a lot of category to show its frequency, because a bar plot will give will immediately let your audience know, like by the length, will immediately let your audience know what is the most important data. You can even rank this. Right? But you can't do it in a pie chart. So I would say that pie chart is the worst. So avoid using it, right? Remember, okay. I think that's it. I still have more like scatter plot, bubble chart, time series data, and yeah. But I think we can cover it later. Or if you want to book a one-to-one with me, you can do that. I'm a mentor in FutureLab. So yes, yeah, over to you, Ziteng. I'm so sorry.
All right, thank you so much, Pik Yin. Oh, I think that was an amazing, sharing session with us. I myself have learned a lot on, how to utilize Excel, especially if, when you do data reporting and stuff. So very insightful. Thank you so much, Pik Yin, for that session. So we have come to the end, but not yet the end of the session. So I have a few announcements to make, but I understand if some of you may need to leave the session first. So I'll make a few announcements and then I'll leave maybe 5 to 10 minutes at the end for any Q&A session, right? Anyone who wants to ask questions, feel free to stay. Okay, so I have a couple of shared slides. All right. So as I've mentioned, FutureLab is a social enterprise, and we love organizing free mentor classes like this, for everybody to join, regardless of your age, your career, or whatever, right? You're able to join all these mentor classes for free. And we really hope that you'll be a part of our mission as well in terms of supporting us to continue running these mentor classes for the public. So shout out to anyone here who is currently a working professional. If you have more than 3 years of experience in your career, we welcome you to apply as a mentor. So feel free to scan the QR code over here. Once you apply as a mentor, you'll be able to conduct mentor classes sessions like this, like Pik Yin today. And you'll also be engaged for various types of webinars, and also get the chance to help mentees through one-on-one sessions as well. For anyone here who is currently a university student and you are looking for an opportunity to develop leadership skills, soft skills, looking for a place to network with mentors, right, for your own career preparation, we welcome you to apply as a campus ambassador as well. So by becoming an ambassador, you actually get to engage with our mentors and also collaborate with them in organizing interesting and exciting career webinars for your community. All right. And last but not least, to anyone here who is who is keen to book Pik Yin for who is keen to book Pik Yin for a one-on-one session, or any other mentors you want to have one-on-one sessions with, do let us know. Okay, please scan the QR code here as well. So if you would like to book a session with a mentor, you would have please scan the QR code and we will assist you on how to do it. All right. So yeah. Once again, thank you so much for joining tonight's session. Okay, so I guess I will save some time for Q&A session if anyone has any. So feel free to, unmute yourself or put questions into the chat box, and Pik Yin will be here to share and answer your question. Okay, very quickly, we already have one question from the floor.
Okay.
We have Gerard. So he's asking, what is the purpose of the pivot table? Right.
So you actually can, pivot table is used to summarize your data. So for example, I want to know what is the percentage of different age group, right, in my data set. I can do that easily with pivot table. So just now I was just showing the count of each age group, but I can turn it into the, percentage of total, right, very easily with just right click and some click. Absolutely. Okay. So that is one of the use of pivot table, but basically it's used to summarize your data, right? If you want to know the mean, or if you want to look at the statistics based on subgroups, right? You can use it with pivot table. It's not visualization, but it's part of data analysis, right? Or if you want to look at how many, like two variables together, for example, age group and also the outcome, diabetes or without diabetes, right? So you can quickly drag and drop in the pivot table, and you will know, okay, how many person from this age group has diabetes, how many person from this age group doesn't have diabetes, right? So it gives you like, an idea of, or it's actually a very common form of reporting, right, in business, which is boring, but still very informative, right? You put everything in a table to summarize your data set. So does that answer your question, Jared? Okay. Okay, I don't know what is absent link. Okay, how do you know if you give an adequate number of a chart in a report or not? Okay, if you give an adequate number, so first you definitely need to do your data cleaning to make sure you don't have outliers, and also you don't have missing numbers or data input that is not compiling to a certain standard, right? For example, unit of measurement, I say meter, but you give me like a centimeter, right? So this is the first step to clean your data, and adequate number of charts. Okay, so so when you're doing reporting, right, you only show the chart that is most powerful. And then you need to think of the story that you want to tell. It's not like you have a lot of chart in a dashboard or a report and it's good already, because because your decision maker might not have a lot of time. So you just get straight to the point. And also you need to, when you're doing slide, you need to take the advantage of the column, the header that you're writing, because that is the takeaway that you want people to obtain from the chart. So you don't want people to look at a chart and make a different conclusion that is not yours, right? They make their own conclusion or own interpretation. So make use of the header line to tell people. So it's not about how many is adequate. It's about the story that you want to tell, and then the message that you want to communicate to that person, to the stakeholders, right? And choose your most important chart. Okay, so I hope that answer your question. Is that a limit of data that can be loaded? Yes, there is a limit. I forgot the number, but there is a limit. So if you have data that is more than the limit that can be occupied by data or by Google Sheet or Excel, then usually we change to another tool, which is R or Python, right, which involves some programming language. But usually for data that is in your business, what you can do is, if you know your data is going to be big, you try to limit your scope. So if you are trying to extract the data, you try to limit the scope. For example, the issue happens between only in Q1, then you don't extract the whole year data. You only extract that quarter data, right, to reduce the data set. So you think of a way that can, if you don't have R or Python or any powerful analytics tool, think of a way to subset your data to narrow your scope to a scope that is of your interest, right? Okay. So yeah, is there any possibility Google Sheet uses virus? I'm not sure about this one. I'm not a expert in cybersecurity, but so far when I'm using Google Sheet, it was okay. Yeah. Anyone else have any questions?
All right. Anyone else would like to ask the last question, maybe? All right. If that is all, Then, okay, so last thing I need from all of you is, if you can, could you scan this QR code and submit your feedback to us? We would like to know what did you think of, the session tonight? Is there any comments or is there any feedback that you would like to give us so that we can, improve for our future mentor classes? That will be very much appreciated. So if you can, please spend some time to scan the QR code and also fill up the feedback form here. All right. So with that being said, I would like to wrap up the session officially. So I would like to take a group photo with everybody here. If you can, please turn on your camera so that, your beautiful face and handsome face will be in the picture as well. So yeah. All right. Thanks, guys. Hi, Niken. Hi, Gerald. Hi, Eric. Hi, Miharbi, Xingyan. Nice to meet you. Nice to finally see your face. Okay, so are you guys ready? If you are, I will take the photo. Okay, so I'll count to 3. Okay, wait, we have a couple more turning on their camera, so let's give them some time. Okay. All right, everyone ready? Okay, I'll count to 3. 1, 2, 3. All right. Okay, we have 2 more screens to go, so bear with me. All right. Smile. 1, 2, 3. Okay, one last slide. You guys ready? Smile at the camera. 1, 2, 3. Okay, thank you guys so much tuning into today's session. Once again, thank you so much, Elise, as well. Thank you so much, Shui Yi. And looking forward to, creating more amazing sessions like this for all of you. All right, so have a good day or have a good night wherever you're at, whichever country you're at. I'll see you guys very soon. Bye.